Let's tour the solar system, shall we? Hop in our time machine back to the solar system formation. The solar nebula hypothesis is a accepted theory on how solar systems begin. Stars form from collapsing nebula, hydrogen as it collapses, mass increases toward the center. Critical mass causes fusion from hydrogen to helium. That's what that powers a star. The solar disk forms around this rotating protostar, and planets form by collision and coalesce, they grow. The astronomical unit is the measure of distance that we use in the solar system, is the distance from the Earth to the Sun, approximately 150 million kilometers, the average distance, or 93 million miles. We have a theory of the anatomy of the sun, a cross-section. Obviously, we don't have direct observations, but through careful study and evidence-based science, we have tried to paint a picture of what the sun looks like. Center of the sun, the core, the temperature is roughly 15 million degrees Celsius. That's where fusion occurs. It's the densest layer. The radiative and convective zones form a solar envelope. Okay, so these photons pass through the solar envelope and then through the photosphere. Photo meaning light that emits the visible wavelength. That's what we can see. Temperatures are about 5,500 degrees Celsius. We know temperature based on color. We know it's called black body radiation. We know the wavelength of light that is emitted with a specific color, so we can postulate the star's temperature, our sun and other stars, based on color. Chromosphere is the reddish layer of rising temperature. Chromo means color. The corona is the outer atmosphere of the sun, visible during a solar eclipse. Sun has many storms. Prominences are big eruptions. You can see this one is a solar flare shooting from the sun, even larger than the Earth. Prominences are solar flares that curl back into the sun because of the magnetic fields. Sunspots are relatively cool, dark solar storms discovered by Galileo. They happen in cycles, and we can measure them and predict future solar activity based on sunspot cycles. We have also correlated sunspot cycles to ancient climate changes. So, for instance, the Little Ice Age in the 17th century was under minimum, a minimum of solar activity. So sunspots are cyclical, and they do affect our solar activity and then our world climate. So the sun's powered by nuclear fusion. It's currently approximately 75% hydrogen, 25% helium, small amounts of heavier elements. The heavier elements form through fusion, helium fusing, elements fusing. So the stars cook up elements that form our solar system. So our solar system and all these heavier elements, the metals and all the atoms that we've discussed, have often formed in stars. Solar wind, leaving the corona and shooting outwards, that is blocked by our magnetic field, thankfully, because we would not be able to survive if we did not have a magnetic field in plate tectonics, because it would literally blow away whatever atmosphere we have. The auroras are visible because of the solar wind superheating plasma in our upper atmosphere. And there's the auroras. The northern lights is the aurora borealis, and then we have southern lights as well. You can see how beautiful they are. That's superheated ions in the upper atmosphere. The upper picture is interesting because you can see a crater in Canada. That's a northern crater. uh, there as well. Evidence of a meteorite impact. And the auroras, of course. I was fortunate enough to see an aurora back in the early 90s. Quite amazing. I only saw the green. I didn't see any other, but it was still an experience that lasted a lifetime. Now, Earth's motions, the rotation, we have the solar day, which would be the noon to noon. And we have a sidereal day. That's because we're also moving around the sun. So solar day, 24 hours. Sidereal day is a little less. Revolution, to go around, you can see elliptical, sun at one of the foci. We are furthest away from the sun, July the 4th, aphelion. We are closest to the sun, January 3rd, perihelion, which should tell you that the distance to the sun, although millions of kilometers different, 5 million kilometers different from one to the other, has little to do with climate. It's the axial tilt. Because July 4th, when we're furthest away, it's hot up here in the northern hemisphere. So that's the elliptical movement of the Earth around the sun. We also wobble in our orbit, and that wobble is called precession. So the stars go through a cycle as well. That cycle is precession. It changes every 23,000 years. Vernal equinox occurs in what we call the age of the zodiac, the age of Aquarius versus the age of Pisces. Interesting story. Pisces, the fish, is a secret sign from ancient Christianity because it was the age of Pisces moving through there, the age of Pisces, in which Jesus was born. So the fish was a secret symbol to avoid persecution. And of course, people get magnets for their cars today with that not so secret symbol anymore, but it harkens back to thousands of years ago. Now, the moon also goes around the sun, not so ironically in an elliptical motion as well. So we are at a focus. It takes about 27 and a third days for the moon to make a trip around us, a sidereal month. 29 and a half degree is a complete lunar cycle. Synodic month, that's because we're moving as well. And 13 degrees difference every day. About 10-minute different moonrise to moonset. So rotation and revolution with the moon are synchronous. The same side of the moon is always facing Earth. And the moon the disk is almost the same size as the sun. When it's closest to us during an eclipse, it would block out the entire sun. When it's farther from us in its elliptical orbit during an eclipse, the sun is larger and it would just look like there was a hole in the sun. The phases of the moon, when it's growing, it's called waxing. When it's disappearing, it's called waning. You can see how you start off with a new moon when it's dark, crescent, gibbous, and then not really a half moon, a quarter, and then gibbous, crescent, full. So you go through a cycle. This is the name of the lunar phase and what it looks like on Earth and its position with the sun. So this particular image is something that you need to study. Eclipses. The lunar eclipse occurs during a full moon when the moon passes in the umbra. It actually turns red because it reflects light coming from Earth. You know, sunrise and sunset appear red. So we get that. That's called the blood moon, of course. A solar eclipse occurs during a new moon, and they're rare, and they only are seen at a small portion of the Earth. A total eclipse would be when the moon is closest to the Earth and the sun totally disappears. An annular eclipse is when the moon is further away from the Earth and it does not make the entire sun disappear. The inner planets are called the terrestrial planets. They are rockier. They're not. They're closer, more dense. Mercury is the closest planet. Observe all of the craters. That is from ancient formation, from collision. It swept out its path quite well. Venus, our sister planet, is only sister in size. She is very, very hot due to the runaway greenhouse effect, sulfuric acid, and carbon dioxide atmospheres. Venus has phases discovered by Galileo. Also, the picture of Venus there, it's also called the morning star, although it's not a star because it's the brightest object in the sky when visible in the morning, besides, of course, the moon and the sun. But there's a picture of Venus close to the moon right there. Mars has the largest volcano we know of in the solar system. It's extinct. It's a shield volcano called Olympus Mons. Astronomers believe there used to be water due to the oxidation, due to the rilles and looking like riverbeds that are now empty. Also, Martian rocks and meteors from Mars have what appears to be fossilized bacteria. I use the word appears to be because you can't prove that it is, but you can see the image below. It looks like some fossilized life. So there might have been ancient Martians, definitely not carrying ray guns. There could have been a planet that should have formed between Mars and Jupiter because the gap suggests that, but never did. There is an asteroid belt there, so we have an asteroid belt. Then gas giants. But our largest asteroid actually has a small moon of its own. So, ironically, the smallest known moon in the solar system goes around an asteroid. The gas giants, of course, mostly hydrogen and helium, very low densities, very rapid rotations. They all have rings and a lot of satellites because of their huge gravitational fields. So Jupiter, the largest planet, Galilean moons, sometimes, the number of satellites, other moons vary depending on captured asteroids and things like that. Great red spot's a huge storm. You can see right there, that storm's been moving as long as we've had telescopes. There's always been there, but it is a huge cyclone. Saturn kind of looks fake when you look at it through a telescope, through a microscope. Yeah, that was great. Very fast rotation, flattened at the poles, prominent rings. Although all the gas giants have rings, some aren't visible without special telescopes. Uranus is one such. It was the first planet actually discovered, not visible with the naked eye. William Herschel discovered it, named it George, by the way, which was rejected by the Astronomical Union. So Uranus's name was originally George. It has a bluish color due to methane in the upper atmosphere. Rotates on its side. It has rings, as you can see from this. So Uranus, or Uranus, has rings. Neptune, god of the sea, King Neptune, because of the blue color, liquid ammonia and methane. It has a dark spot on it, which we believe is a storm as well, called the Great Dark Spot. There it is, Great Dark Spot. Our moon, of course, we've been to, and we know quite a bit about just from direct observation, direct studies. But the solar system has many, many moons. Now, Mare and Highlands, the Mare come from Maria, marine. They were thought to be huge oceans, but they're really flood basalts due to volcanic activity. And the Highlands are craters and volcanic. The moon has a thin atmosphere, very thin atmosphere, very weak gravity. That's why the atmosphere is so thin. The moon has an elliptical orbit, 29 and a half days to complete one full orbit. Rotates on its axis, so the same side always faces Earth. Titan, which St. Pete College's mascot is a Titan, ancient god, is also a moon of Saturn. Shepherd moons are moons that keep the rings together on Saturn as well. So Titan is a moon of Saturn. Uranus has 5 large moons. One is Miranda, which has been shattered and reformed. Triton is the only moon that is the coldest. It's cold and it has a retrograde orbit. So Triton is the only planet with a retrograde moon. Coldest object in the solar system. Rings, all Jovian planets, which are Jovian planets are gas giants, have rings from asteroids that have been pulverized by the great gravity of that planet. Comets are huge ice and gas clouds. Notice they take wide, cigar-shaped elliptical orbits around the sun, and the tail always points away from the sun because the tail is actually formed by solar wind, not the comet moving. So here's an actual comet and its parts. The nucleus is the snowball itself, the coma, ion, and dust trail. Shoemaker-Levy 9 was a comet that impacted Jupiter in 1994, and it was the first and only impact that humans have ever witnessed and filmed. I saw the picture above happen in live time. I was at a diner, and it was a Friday night, and then I was leaving the diner, and I was on a county road up in Westchester County, Putnam County area, and I heard crackling and turned to the left and looked as I was driving down this road and saw a fireball fly across the sky. It was, I could feel the energy as it whizzed by. It did strike in Peekskill, hit a car as a matter of fact, and it was a fairly famous, one of the first filmed on home videos because it was a Friday night during Friday Night Football, and a lot of people caught it on video, and I got home and saw the news and saw that it was, in fact, a fireball, a shooting star, a meteor that entered our atmosphere and struck. So the 3 types of meteorites, what they're made of: stony, iron, and then carbonaceous. And that carbonaceous has organic compounds, and it could be linked to the first organics that made it here on Earth. I talked about an impact crater when we looked at the Aurora picture, and there it is, right in Canada, a very famous impact crater that we only can see from space because it's so big. A meteor crater in Arizona is also a very famous crater. So we do have craters that have evidence of huge impacts on Earth. Trans-Neptunian objects are objects that are beyond Neptune. The Kuiper Belt, the scattered disk, and the Oort cloud we'll touch upon. The Kuiper Belt are objects, and Pluto actually is a Kuiper Belt object with its moons. Pluto, it used to be a planet, but it's really part of a larger group of bodies that orbit the sun in trans-Neptunian orbit called the Kuiper Belt. So there's Pluto with its moons. It's also called a dwarf planet now. My wife still gives me the business about Pluto no longer being a planet, but according to definition, it does not fill the bill. Scattered disk objects are icy objects that overlap with the Kuiper Belt. And then the Oort cloud extends a light year. It's basically everything in the sun's gravitational influence. Jan Oort, the first scientist to describe it, it is believed to be the remnant of the protoplanetary disk.